duration of physical activity versus blood pressure of selected individuals. When these paired variables are ranked, is it possible to determine a correlation between them? Hello, Sci Pals! I am Ma'am Marga Calvenda, your science teacher for today. In this episode of Agham Alam Hub, we will discuss the Spearman rank correlation coefficient. We will also identify the assumptions required for Spearman's rank to give a valid result. We will also solve a problem using Spearman's rank correlation coefficient. Furthermore, we are going to appreciate the importance of Spearman's rank correlation coefficient in research. In the next few minutes, we will explore science for another moment. The Spearman's rank coefficient of correlation, or Spearman rho, is a non-parametric measure of rank correlation. It is named after Charles Spearman and is often denoted by the Greek letter rho, and is primarily used for data analysis. It measures the strength and direction of the association between two ranked variables. Spearman's correlation coefficient is a statistical measure of the strength of a monotonic relationship between paired data. In a sample, it is denoted by and is by design constrained as follows. Its interpretation is similar to that of Pearson's, which was discussed in Agham Alam Hub's episode 19, Pearson Product Moment Correlation. For example, the closer is the Spearman's rank value to +1, the stronger the monotonic relationship. Correlation is an effect size, and so we can verbally describe the strength of the correlation using the following guide. For the absolute value of Spearman's rank coefficient of correlation. The Spearman's rank can take a value between +1 to -1, where a Spearman's rank value of +1 means a perfect association of rank. A Spearman's rank value of 0 means no association of ranks. And a Spearman's rank value of -1 means a perfect negative association between ranks. Take note that the closer the Spearman coefficient value to 0, the weaker is the association between the two ranks. When you choose to analyze your data using Spearman's rank, part of the process involves checking to make sure that the data you want to analyze can actually be analyzed using a Spearman's rank. You need to do this because it is only appropriate to use a Spearman's rank if your data passes 3 assumptions that are required for Spearman's rank to give you a valid result. These 3 assumptions are: Assumption 1. Your two variables should be measured on an ordinal, interval, or ratio scale. Examples of ordinal variables include Likert scales. It could be a 7-point scale from strongly agree through to strongly disagree, or a 3-point scale explaining how much a customer liked a product, ranging from not very much to it is okay to yes a lot. While examples of interval or ratio variables include revision time, which is measured in hours, intelligence, which is measured using IQ score, exam performance, measured from 0 to 100, and weight, measured in kilogram. Assumption 2. Your two variables represent paired observations. For example, Imagine that you were interested in the relationship between daily cigarette consumption and amount of exercise performed each week. A single paired observation reflects the score on each variable for a single participant. In this case, it would be the daily cigarette consumption of participant 1 and the amount of exercise performed each week by participant 1. With 30 participants in the study, this means that there would be 30 paired observations. Assumption 3. There is a monotonic relationship between the two variables. A monotonic relationship exists when either the variables increase in value together or as one variable value increases, the other variable value decreases. Whilst there are a number of ways to check whether a monotonic relationship exists between your two variables, we suggest creating a scatter plot where you can plot one variable against the other and then visually inspect the scatter plot to check for monotonicity. Your scatter plot may look something like one of the following. Spearman's rank measures the strength and direction of monotonic association between two variables. Monotonicity is less restrictive than that of a linear relationship. For example, the middle image shows a relationship that is monotonic but not linear. A monotonic relationship is not strictly an assumption of Spearman's rank. That is, you can run a Spearman's correlation on a non-monotonic relationship to determine if there is a monotonic component to the association. It is also worth noting that a Spearman's rank can be used when your two variables are not normally distributed. It is also not very sensitive to outliers, which are observations within your data that do not follow the usual pattern. Since Spearman's correlation is not very sensitive to outliers, this means that you can still obtain a valid result from using this test when you have outliers in your data. Now, let us try to use Spearman rank correlation coefficient in this problem. Find out if physical activity has any relation to blood pressure at alpha 0.05. In column 2, we have the number of minutes that 10 male students of the same age spend daily in a gym, and in column 3, we have their systolic blood pressure. Step 1. Create a table of the data obtained. Step 2. Start by ranking the two data sets. Data ranking can be achieved by assigning the ranking 1 to the biggest number in the column, 2 to the second biggest number, and so forth. The smallest value will usually get the lowest ranking. This should be done for both sets of measurements. Add a third column D to your data set. D here denotes the difference between ranks. For example, if the first student's physics rank is 3 and the math rank is 5, then the difference in the rank is 2. In the fourth column, square your D values. Step 4. Add up all your D square values, which is equals to 290. Step 5. Insert these values in the formula. With D squared equal to 290 and N equal to 10, the formula undergoes the following transformations. Rho is equal to negative 0.7576. Step 6. Using this table, how are we going to describe the strength of correlation based on the computed value? Since the computed Spearman's rank value is negative 0.7576, it can be interpreted that there is a strong correlation between the two variables. Additionally, since the computed value is negative, we can say that there is a strong negative correlation between the physical activity in minutes of the 10 men with their blood pressure in millimeter mercury. Remember, if there are tied ranks, we will use this formula instead. But we are not yet done. We only found out that there is a strong negative correlation between the physical activity in minutes of the 10 men with their blood pressure in millimeter mercury. The next question is this correlation significant? The significance of the Spearman rank correlation coefficient could be tested using the table of critical values of Spearman's rank correlation coefficient. Here is the table used to determine the critical values of Spearman's rank. The computed Spearman's rank value is compared with the tabular value with the number of samples and at a specified level of significance. If the computed Spearman's rank value is greater than the tabular Spearman's rank value, then there is a significant correlation. Now, to interpret the computed Spearman's rank value, we may use this table. For our null hypothesis, there is no association between the given pair of variables. For the alternative hypothesis, there is an association between the given pair of variables. The level of significance or alpha value is set at 5% or 0.05. In Spearman's rank, our DF is simply the value of n, which in this case is 10. Based on the table, the Spearman's rank critical value is 0.648 at 0.05 level of significance. Let us compare the Spearman's rank computed value and the tabular value. If the computed p-value is lower or equal than the tabular value, it means that probability of occurrence of our actual observation is low if null hypothesis is true. Thus, we can say, accept null hypothesis when computed p-value is equal or lower than the tabular value, or reject null hypothesis and accept alternative hypothesis if the computed p-value is greater than the tabular value. Now, let us decide whether to accept or reject the null hypothesis. The Spearman's rank tabular value at 0.05 level of significance is equal to 0.648, while Spearman's rank computed absolute value is 0.7576. Since the computed absolute value is greater than the Spearman's rank critical value, we reject the null hypothesis in favor of the alternative hypothesis. Please note that since the distribution of Spearman's rank value is symmetrical when Spearman's rank value is 0, the sign of Spearman's rank value is ignored and thus the absolute value is used. In conclusion, there is a significant strong negative correlation between the physical activity in minutes of the 10 men with their blood pressure in millimeter mercury at 0.05 level of significance. Now, it's your turn. In a study about the growth of Maya bird, the relationship between the mass of the eggs and the mass of the young birds on hatching was investigated. Is there a correlation between the mass of the egg in grams and the mass of the chick in grams at 0.05 level of significance? The data gathered are presented in the table. Calculate the Spearman's rank correlation coefficient of the data. Find out if the computed Spearman's rank correlation coefficient is statistically significant. Also, fill out the table of procedures in hypothesis testing. The Spearman's rank correlation coefficient is a statistical test that examines the degree to which two data sets are correlated. While a scatter graph of the two datasets may give the researcher a hint towards whether the two have a correlation, Spearman's rank gives the researcher a numerical value on the degree of correlation, or indeed, the degree of non-correlation. It is a relatively straightforward analysis for those researchers whom are not wholly confident in their mathematical skills. In this episode of Agham Alam Hab, we have discussed the Spearman rank correlation coefficient. We have also identified the assumptions required for Spearman's correlation to give a valid result. We also computed for data or problem using the Spearman's rank correlation coefficient. Lastly, we appreciated the importance of Spearman rank correlation coefficient in research. We learned that the Spearman's rank coefficient of correlation, or Spearman rho, is a non-parametric measure of rank correlation and is primarily used for data analysis. It measures the strength and direction of the association between two rank variables. Spearman's rank correlation coefficient is a statistical measure of the strength of a monotonic relationship between paired data. We also learned that there are three assumptions of Spearman's rank when analyzing your data. These are: your two variables should be measured on an ordinal, interval, or ratio scale. Second, your two variables represent paired observations. And third, there is a monotonic relationship between the two variables. We have also computed for data or problem using the Spearman's rank correlation coefficient. We use this table to describe the strength of correlation based on the computed value. If the computed value is positive, there is a positive correlation between the variables, while if the computed value is negative, it is interpreted as having a negative correlation. We also learned that when computed value is lower or equal than the tabular value, it means that probability of occurrence of our actual observation is low if null hypothesis is true. Thus, we accept null hypothesis when computed value is equal or lower than the tabular value. Or, we reject null hypothesis and accept alternative hypothesis if computed value is greater than the tabular value. Finally, we learned that the Spearman's rank correlation coefficient is a statistical test that examines the degree to which two data sets are correlated. While a scatter graph of the two data sets may give the researcher a hint towards whether the two have a correlation, Spearman's rank gives the researcher a numerical value on the degree of correlation, or indeed, the degree of non-correlation. It is a relatively straightforward analysis for those researchers whom are not wholly confident in their mathematical skills. That's all for today, SciPals. Don't forget to like, share, subscribe, and turn on the notification bell. See you again next week for another moment. Only here in Agham Alam Hab, Palagian's SciTech Portal. Bye!